Welcome to another fun-filled lesson on intermediate C++. Today we will be covering namespaces. So get ready for more thrills and spills and pills. Okay, now up till now we've always seen the line in your code says using namespace std, your standard namespace, and it may have occurred to you, why do I always have this line in there? Well, the reason why you always have that line there is you want the standard namespace to be your default. It doesn't have to be. As you get out into the world, you'll see a lot of programmers deliberately avoid that. And so instead of saying cout, they'll say std : cout. We'll see a little bit about that. What namespaces do for you? They prevent name collision. You can buy software from this vendor, you can buy software from that vendor, you can incorporate them both. This vendor has a function called add. It's a very common word. He wants to use the word add because he wants to add stuff to his collection or data or whatever he's got. This guy's got something else that says add. Well, how do you tell which add you want to use? Well, you come up with a namespace. You can have this guy that you bought his software for, he will have defined all of his names in a particular namespace that he will define unique to his company. He will have done the same thing for his company. You can bring them both together as long as you identify based on the namespace you're using. There's no collision of name. You don't cause problems. So we'll see how to define our own namespace, because you want to write some software, you might want to sell it to somebody, you need to put your stuff into a namespace. Now you can have as many compilation units all in the same namespace. You've got the unit of code, you've got the namespace, and they can overlap, and whatever it happens to work out best for you. You can have a compilation unit that has different namespaces in the same compilation unit. You can have different compilation units in the same namespace. You merge them any way that makes the most sense for your application. So we also have a scope operator for your class, which is not quite the same thing as a namespace, but looks like a namespace. But it doesn't work the same way as a namespace. So you can't use it to duplicate names in multiple compilation units quite so much. You can use it for your class definitions quite a bit. But there's things where if I have a variable, I have an integer in this compilation unit, and it's called A. You can't have the A in another compilation unit because it will go to the linker. It says, I'm looking for an A. I'm going to define an A here. There's other compilation units. I'm going to define an A here. The A's will clash with each other. So it's more for your types and classes than for an actual class instance, your object instances. So you can use explicit scoping for, you can say, I want to use a particular namespace. You can say, I want to use this, each one of these namespaces, as long as the names that you use are unique between them, that you won't have any clashes. So that's what your using keyword does. It sets up your default namespace. Your explicit scoping is, I want to say std : cout, for example. So I don't want to have a using keyword. Like I say, many organizations deliberately avoid the using. They don't want to have any confusion at all. They don't want to run into an issue where they think of a wonderful name for their code. But I want to have this particular function be called this, and find out it's already defined in the standard library someplace. So, geez, now we can't use that anymore. So they will very deliberately avoid putting a using on their code, and which is okay. It's a little cumbersome for the programmer because he has to type std : every time he uses something. But if that's the company policy, you go with company policy. So you can specify a particular name. Says I want cout to be from the standard library, so I'll define cout to be from the standard library. And there are strategies. There's a very common strategy. There are uncommon strategies for deciding, okay, I'm going to sell this package. I'm going to have my namespace. What name do I give the namespace? We'll talk about that. And we'll talk about using namespace aliases, because after you come up with a name for your namespace that you know is unique, it might be a little long. The people using it says, I don't want to use that big old long namespace. I want a short namespace. Well, use an alias to define your short alias to whatever the long namespace alias happens to be. So the namespace uses the scope operator, which is 2 colons. It's an operator, incidentally, that cannot be overloaded. One of the few in C++ that you are stuck with. You can't say, well, I'm going to have : mean add in my... No, you can't do that. We've seen 2 types of namespaces. There's the std for the standard library, and in object-oriented programming we have seen where you can associate a class name with a class method using the same scope operator, which is not quite the same thing as a namespace, but it's similar. So it's advisable for packages intended to be included in development by other organizations. If you're never, ever going to sell your code to anybody else, it's never, ever going to be included in somebody else's package. You don't have to worry about it so much. But if you're doing that, what are you writing your code for? Well, I guess you're writing the entire application all by yourself. It's very likely, though, that your code will be included in someone else's code. You will get someone else's code to include in your code. So it's advisable to set up your namespace policy. Because otherwise, you want to avoid namespace collision. You don't want this guy to have a subtract method, and you have your own subtract method, and you want to avoid the subtract being confused, or especially with classes. Company as a class name. Every lesson, every class in computer science, every homework has got, okay, define a company object. Okay, well, somebody will have a company object. Define an employee class. You got an employee, and we'll call it employees. Well, you bring in something and they define an employee, you bring in something else. They've also defined an employee class. You've got to tell these two employees apart. Well, you set up your namespace. So you separate the names according to the organization that the names are included in. So the class association namespace, it's not strictly a namespace, but it's a scope. You're defining that this particular method belongs to this particular class. So our example, we'll have in our header file, for example, we'll define our class and we'll call it my class. That's an inventive name because it's my class, it's not yours. And we'll have just the one variable to integer. Our public methods is, of course, we have a constructor, and then we have another one. It's my method. And we pass it a parameter. And so this is just the declaration. This is just a prototype of the class. This is what you input in the header file. You don't have any implementation code in this. So when you have a separate file that implements the my method, well, how do you say this method belongs to my class as opposed to belonging to your class or his class or whatever? Well, you've got the name of the class that it belongs to, your scope operator, here's our constructor, and here's the implementation of the constructor, where we're just, this is a default constructor, we're just saying the variable equal to 0. Here's our my class, here's the scope operator, here's my method. So here we are associating that class, my class, with my method and passing the param. And here's our implementation of that method, which is calling some other functions from somewhere, which maybe some other, you may need another scope operator right here to go, depending on where some process exists. It might be another method inside the class which needs to be defined up in your header file. But however you have it set up, this is where you're associating that this method belongs to this namespace scope. So when you're writing some code, you're going to give it to someone else, and you want to make sure your namespace is unique, and all the names inside your namespace are unique. You need to define the namespace. So that's where you have your namespace keywords, easy enough. So you have the keyword, an identifier, and a block to add the names into your namespace. So basically, you have your code that you're running and working, and you put your namespace block around it. That's all you have to do. Very simple. So now we have namespace mine, open the brace. Everything inside this block is added to mine namespace. We have another one here. Oh, by the way, it's also a good idea, particularly for namespaces, is on your closing brace, add a comment. If you're using the Eclipse IDE, it'll do this for you automatically, so that you know that this closing brace is closing off this particular namespace. So here's one that's namespace yours. Now here we have integer A, integer B. They're set to a couple of initial values. Here we have double A, double B. It's A and B. This is all inside the same compilation unit where you can get away with that. It's multiple separate names compilation units. Your namespaces won't work quite that well. But inside this compilation unit, you can say mine, double quote A. You want to print that out, and it will print out 3. If you say yours as your namespace and your scope operator A, it'll print out 5.5 because that's what A is in the yours namespace. And again, you're assuming that all this code has got using namespace std in front, because otherwise you would have to have std and a namespace in front of cout, also in front of endl, which is also in the standard namespace. Now, various units can share the same namespace, and if you're a company, you're producing an application and it's got multiple compilation units, you'll probably want them to do that. You want them to all be in the same namespace. So all your different include files for your standard library happen to be in the std namespace, which is why all the code we've written up till now has always said using namespace std. Because every time we want to bring in a library from the C standard library or the C++ standard library, we know that's in the std namespace, and we don't want to have to put std : in front of everything. So all those various compilation units are all independently part of the std namespace. So just basically include the same namespace declaration block in each compilation unit. So here we have a compilation unit alpha.cpp. And namespace mine, and we got class alpha and blah blah blah, whatever else you're declaring, all the information, all the attributes, all the methods, all of it, going to the alpha CPP. Here we have a separate compilation unit called beta, and we have again namespace mine. So alpha and beta are now all both part of mine namespace. And of course there would be a closing brace at the end of this, plus a comment that says you're part of the namespace. But I didn't write all that code. So we use our namespaces for types and for classes that they're going to be implemented in the application code. So here we have alpha CPP. Here we have namespace alpha. We have my class, which is now part of the alpha namespace. The var constructor, a little comment that says this is the end of my namespace. And here we have a separate compilation unit called beta, and we just happen to have a separate namespace for that. And again, it's called my class. Now, my class, very inventive name, but it's unique because it's part of the beta namespace as opposed to the alpha namespace. So when we need to implement the particular class, we'll just implement it with our namespace, our scope operator, the colon, and then the name of the class from that namespace that we want. So now we have A1 is a instance of the alpha my class, whereas B1 is an instance of the beta my class. It's all pretty straightforward, pretty easy to work out. Now, I mentioned briefly, it's not a good idea to try to use a namespace for an instance, particularly in different compilation units. It's not that sophisticated as to work those out for that. For example, we have alpha CPP, we have integer var, and we'll have another compilation unit, beta CPP, namespace beta. Now we have double var, we set it to 5.5. Now these are in separate compilation units. So when you compile this code together, it will compile an object code for alpha. It will compile an object code for beta. They will get linked together. Then the linker will say, hey, I've got duplicate definitions of the variable var. So it will complain about that. It won't complain at compile time. It'll complain at link time. So basically, it's not a good idea to have variables like this defined inside. This is a global variable. This gets to your global variable problem. And you don't try to use a namespace to solve the global variable problem. There's other techniques we'll talk about later. So you can also use an explicit namespace. We have our header, our namespace mine. The class is my class, and rather than you can say using namespace mine, or you can just say mine my class, and then when you want to call that method, you can say mine, and then MC, and then call the method of the MC, or the MC stands for my class, and that it will go in there and use that particular one based on the mine namespace. Now, the using keyword lets you set up a default. So you can specify a default namespace for all the objects in a particular compilation unit. Now, up until now, we've been using the STD and having that as a default. So we have that. Now, where you put it defines where that default is defined. We've been doing it right at the beginning of the file to cover the entire file, the entire compilation unit. You can also put it inside of a block. So we have integer main. Now, this is the block that starts your main function. And now we have using mine. So the mine namespace is added to the list of default namespaces just for this particular block. And I ran out of space, so I put it there. And then we can have another one. Now we have another block here. You have x is greater than y. Now we have another block. So now we have the namespace yours is added to the list of defaults for just inside this if statement. So you can use more than one using each one that you have gets added to the list. As long as there's no duplicates between them, there's no conflicts. Everything will work fine. So any name that could be found in more than one must be explicitly named. So if you've got my class, right here, if we were inside mine, right here, right after the main, and if I use my class, and it happens to be part of the namespace mine, not a problem. Now we come over here, and we want to use my class again. Let's suppose there is a my class in yours, as well as in mine. Now inside this, since we've got STD, mine, and yours have all been defined as default namespaces, here you would actually say, which one do you want? Do you want yours? Do you want mine? I will presume we want yours, which is why you set that up to be a default. And once you leave that block, the yours is no longer applicable. So now when you go to my class, it will go back to defaulting to just mine. You don't need to put the scope operator on again. But of course, these types of games can get confusing. You're probably better off to just, when you have this type of situation, always explicitly set the namespace. Not to mention the fact that sometimes when you're going through debugging code, you say, well, I need to take some code and take it out of this group and put it into that group, which suddenly changes its namespace space. And now all of a sudden code that used to work doesn't work anymore because it's now going to the wrong namespace. So you're probably better off to always explicitly put the namespace, which is why many companies make that the rule for their developments. We'll just always put the namespace explicitly. So that's where we're avoiding the using. We don't want to have a default namespace because of issues of, we don't want, for one thing, when we put a header on there, if you create a header, and if we say in there, well, we're always going to be using standard. So you say, well, we're going to say using namespace, and let's say it's mine. And let's say that's part of your header. Now what happens when your caller includes your header, guess what? Your namespace now becomes his default. And your caller may not want that. And there's no command to say remove namespace. So if you have a header that's going to be included by other callers, you're probably better off to leave the using statement off inside your header. So if you're using the standard namespace, because you have a standard vector, just go ahead and put it on there explicitly. I mean, that's probably why they made it STD instead of standard, because they don't want to type that much. So here we have a vector, and we want inside the vector we want to do some output. So we want to use the standard cout, and we want to use the standard L at the end of our line, etc. And here's a standard vector here. So these are the things that are set up in here. Now, inside your CPP, inside your compilation unit, you don't have to be quite so strict about it, because your compilation unit will be compiled independently, and then the object file will be linked with the rest of the application. But once you're in the habit of always putting the namespace, you might as well just always put the namespace. Now, you can use the using keyword for specific names. So like, for example, we have cin. I use cin all the time. I use cout all the time. I don't want to have to do std for that. So I say, well, I will just say using std cin. So now for cin and cout, I don't need to put std : in front of it. So you can avoid using the namespace name for particular names. It doesn't force the entire using on callers. So now you don't have the std namespace forced on all the callers of your particular subroutine, but it does force cin, cout, whatever else you've defined to be the default for your callers. Your callers may not appreciate that. So again, this is back to something, this is the type of stuff you probably do not want to do in your header files that are going to be included in other people's code. But inside your independent compilation unit, and I don't want to type std all the time. Oh, okay, well, you do something for that, and now you can just do cout and cin and not have to worry about it. But inside your compilation unit, which is independently compiled, not inside your header file, which is included in other people's compilation units. Now, we talked briefly about having a naming strategy. How do we come up with a name for a namespace that we can guarantee that no matter who in the world buys or uses this software, you won't have a naming conflict? So we want a unique namespace. It doesn't have to be worldwide. You don't know who on the planet is going to say, hey, he's got a great subroutine there. He's got a great class. Let's use his class. He's published it on the web or whatever else. It does exactly what we need. Let's download it and compile it. It could be in Russia. It could be in Hawaii. It could be in Minnesota. It could be in South America. You don't know. How do we handle this problem? You can't just think of a name like Charles and think that's going to be unique. Actually, it probably would be unique, but never mind. So we need to avoid the possibility the customer will use your package and someone else's with the same name. So the typical advice that's been given, since you have to have a unique website for your company, because if you want to have your company have a presence on the web, and nowadays every company wants to have a presence on the web, and the web companies that handle giving out domains and stuff already guarantee that is unique. So it would get to be a problem with some people. Like there's a Nissan who has his own computer company. Nissan is his name. Now, there's also Nissan, the company that makes automobiles. So you can't have two Nissan.com. The guy who has the computer company happened to come first. So he's got Nissan.com. The other company, the automobile company, says, NissanUSA.com. But the point being, those two names for those two separate companies are unique names. So, hey, we'll use the website name, the URL, our domain name. We make that. So for example, we've got www.mycompany.com. And, well, we don't really need the www part since everybody has that, but the mycompany.com is guaranteed to be unique worldwide. So we'll have a namespace for our products at My Company. We'll call it My Company, and we can't use a dot, so we use _com. So if someone else comes up with another similar, and this does happen, there's occasions where you have, someone's got a .org, so a completely different company has got a .net, a totally independent company has got a .tv because they're in the Tuvalu, which is where the TV comes from, or .uk in England. So not a problem because we've got that included. So we'll say My Company _net, for example. So when that becomes a namespace for your products, your namespace and the names inside your namespace are unique worldwide. Now, a company might even want to go further than that. So we've got several products, and we want our several products to have unique names. So that's fine. Okay, we'll have My Company _com _product _alpha. Or just alpha. But don't call it alpha because that might not be unique. But My Company's com product alpha, or My Company com product beta, or maybe you want to say com alpha, com beta. It depends on the company, whatever they want to do. And this is a little long. That's all right. We'll just use an alias. That way, we'll shorten it. So we'll have namespace alpha equals My Company com product alpha because we're using that company's alpha products. We're also using that company's beta products. We don't want to have to type out My Company com product alpha : so we just use alpha : for whatever the classes and objects that we're bringing from this company, and then beta because we've got a namespace beta to have something shorter so we don't have as much typing. Kindly don't use A, B, C, one letter. I know it's easier on the typing, but you'll confuse people. You're better off with something, at least as long as a word says this is the product whose namespace we're bringing in. So, have we avoided enough duplicates today? This obviously is the beta version. So, and that's it for today's class on Intermediate C++. I'll see you next time.